So it's a cost of living. Can I see your? Yes, laptop. Thank you. Where we produce data for every, we're getting to there where we're going to be producing data for every state. And it's a cost of living benchmark, and it's used by policymakers and nonprofits across the country. And so for more than 50 years, we've been building this in Excel, typically one single state at a time. And now, over the past year, with support from the eScience Data Science Accelerator program, we've been transforming this workflow from a single state Excel process to a 50 state production pipeline in R, and finally in GitHub, like normal research scientists would. So over the past year, there's been a lot of shifts that have happened. And so that's what we'll talk about today, what's happened technically and as well organizationally. But first I want to start with a little background, and I'm going to start that with a conversation I got to have recently with my 18-year-old nephew, who was helping me cut up a huge pile of apple branches. He's taking a personal finance class, and he comes up to me and he's like, so did you know that there's an income measure that determines whether you qualify for government programs? And that it's just like one number. Just like, I think I'm, a little familiar with it. I know a little bit of something about that. So I asked him, well, did you know that that income level is the same whether you live in Olympia, that's where we live, or Seattle, or New York City, or Kansas? And he was like, aha. And I was like, and did you know that it doesn't change for kids' ages? So it would be the same for the number of children. So for you or for my son, who was 5 years old. And he laughed and made a joke about how he probably ate a little bit more food than my 5-year-old. He's 6'4" with a baseball scholarship and has like 3,500 calorie goals every day. So his next question from that was, well, what do you think, how much do you think it underestimates how many people are actually poor? And I said, well, that's a really good question. And that's basically why the self-sufficiency standard exists. So the Molly Oshansky here is from the Social Security Administration, and she developed the poverty threshold back in the 1960s. So back then, families spent about a third of their budget on food. So she took the cost of groceries and just tripled it. And then that formula, food times 3.
Can minimize the.
Yes, definitely. Thank you.
Still getting used to this Zoom and in-person presentation format. It's either one or the other, not both.
Yeah, I think this is my first Zoom and in person. Mm-hmm. And so, okay, so that formula, food costs times 3, that is what sits underneath the federal poverty guidelines that are used for eligibility programs like SNAP, that's food benefits, and Head Start, preschool for children, WIC, it's a food program for pregnant women and infants, and hundreds of other programs. And that methodology hasn't changed since the 1960s, except for being updated for inflation. But ultimately, costs for families have changed a lot since then. Housing, childcare, transportation, taxes, all of those costs have gone up so much more than groceries. So ultimately, the poverty line that we use, that benchmark for eligibility programs and to understand who's poor, it gives us a measure every year of some like pretty deep deprivation, but it does not tell us, when families are actually making enough, if they're being able to meet their basic needs, if they're not, kind of in extreme risk of hardship. And I think that that's where the self-sufficiency standard comes in. And that's what we produce here. It is a data-driven measure of what a family really needs to meet basic needs. So instead of looking at food times 3, the standard builds a full market basket of costs. It says, what do families need for rent and utilities? Childcare for parents to work, groceries to cook food at home, commuting costs to get to and from work, health insurance premium, out-of-pocket costs, taxes, broadband, cell phones, clothing. And this also takes into account any tax credits that families might qualify for.
So one thing you may have heard of the MIT living wage. Think of the standard as the very present, no arguments measure. You know, in our current political climate, it would be very easy to see Congress saying someone doesn't need funds for their child to, you know, play baseball or do music lessons so that they can develop an extracurricular that will help them get into school. But it's very hard to argue that families don't need, say, transportation, healthcare. And by healthcare, I mean the premium associated with employment-sponsored healthcare and out-of-pocket costs, things like that. There are not any extras in this budget. There is no eating out. There is no Netflix to plop your 4-year-old in front of the TV so you can just breathe for a moment. Nothing extra.
It's enough to just cover your basic needs. No extras like saving, eating out, or vacations. And we assume no public or private assistance. And what that means is we're not assuming the costs of having a grandparent or a neighbor watch your children for while you work or occasionally. Like it is the cost of like purchasing childcare in the marketplace. And we calculate it separately for each county for over 700 family types. So the poverty threshold is the same throughout the entire United States, except for a small differentiation for Alaska and Hawaii. But otherwise, it's the same across all the states. And that means that instead of just generating that one number, we're generating thousands of thresholds every year. And that's how we get a really detailed picture of what it costs to live and work throughout the United States. So when you compare the self-sufficiency standard to the federal poverty line, the gap is huge. Now, this is an example for Seattle from 2025. Both of these lines represent households with 2 persons. So the federal poverty guideline is around $1,700 per month for a 2-person household. But you can see if we price out the cost of basic needs, you know, housing, childcare, rent, and food, it's going to be very different if we're making assumptions around 2 adults with no children versus an adult who also has childcare costs. And, you know, here we're assuming 1 bedroom for 2 adults versus 2 separate rooms for an adult and a preschooler. And geography also really matters enormously. Costs vary dramatically across counties. Rural, suburban, urban. This map here is for Oregon for a family with, let's see, it was a single adult with 1 preschooler. Looks like it's covered up over there. And our estimate is that the variation in what they would need to meet their basic needs would vary from around 51,000 annually to over 88,000 annually, just within 1 state. You know, if we look at it nationally, you know, you can get a sense of like how much variation there could really be by basic needs. So we're not producing just one number like a poverty threshold. We're producing thousands of geographically specific, family specific calculations each year. And for more than 20 years, we were building all of that in Excel. Now, in Washington State, if we talk about the poverty threshold and compare it versus like the self-sufficiency standard, our estimate finds that over 28% of households in Washington State a few years ago were below the self-sufficiency standard. And in that same year, 10% of households were considered poor under the federal poverty line. So these measurements, these thresholds that we're choosing to use really matter when it comes to policy, and they shape how we understand economic insecurity. And we think that when we're shaping public understanding of what need is, the production system that you use and how you produce those numbers really matters. So let me tell you a little bit about how our partners use it. We've been around for over 20 years. Been producing states data for across the country, and we have partners that use the standard to set benefit thresholds, income levels for benefit thresholds, that shape workforce programs, that argue for fair wages, that track economic well-being. So when we make a methodological change, or if we were to introduce an error, it's not going to just stay in a spreadsheet. It could show up in policy. It could show up in data used by a case manager sitting down with a customer, talking about their career pathway. So for us, it's really important that that data needs to be right. And that's where Excel, as good as it was, started to become a constraint. We were checking that data over and over and over again. And it required a lot of manual checks, and we were missing that kind of larger workflow picture. And Sarah's going to tell us a little bit more about that.
So what you see here is what I saw on my first day at the Center for Women's Welfare. I am not I'm a trained researcher in public health, but I'm not a data scientist. But out of necessity, in a previous role, I learned the rules of data normalization, built a relational database. Yes, it was an Access. I know all of you are like, SQL, I do that in my sleep. But it was very startling to be presented with this diagram, starting on the left with all of our components of the self-sufficiency standard, the sources where they came from, and then the arrows drawing to county workbooks versus state workbooks versus templates, inputs, outputs, copy, paste. It made my head spin. I had grown quite accustomed to being able to enter data once and trust it through links and primary keys, and then I would package it off and send it to the organizational psychologist to run their stats, and I would just check their scoring methods. So coming in here, I have to say I had a little bit of an ego problem going, we're still doing what? But there was so much more going on here. It wasn't just about tracking multiple data streams from patient outcomes and healthcare. It was about pulling in all of these data sources and sending them through the complex formulas of federal and tax systems. To be fair to Lisa, when she first started with the standard, they were entering data line by line, one county at a time, and running states that way. A couple people just sitting there reading it off and checking it. Which, if you're running Washington State, might not be too bad. But once you get to Texas with over 260 counties, that's a long night. I think I pressed it once. So Excel. It was good, it was bad, and it was ugly. Good, it was more advanced than before. Like I said, when Lisa joined, they were going row by row, line by line, manually entering data. Good thing about it was also that it performed those iterative calculations. So let me give you some context here. There are other cost of living measures out there in existence. However, to our knowledge, we are the only ones that take taxes and tax credits into account. Others may say they do, but the problem is when you set a wage based on a family needing, say, $75,000 a year, and you apply taxes on it, the net tax liability is going to cause that family to have less than that 75K needed to cover all of their costs. So Excel allowed us to build an iterative tax calculator that would titrate the income up and down using state and federal tax formulas, tax credits, etc., so that when we got that final number, everything was accounted for. Someone wasn't left in deficit. And that was pretty incredible. It also allowed us to manually override certain costs. We could model a family's SNAP benefits. We could set housing to 30% of a family's budget and really just see what those numbers would look like and present them to policymakers. The bad. Well, we were stuck naming and dating files with our initials, confirming with each other that we were all signed out, validating and dating each and every data point. When we would move formulas across, they would break midway. Changes had to be made state by state since there was not one single template. And the ugly. We had a lot of we had the potential for a lot of hidden errors. You know, the call wasn't coming from inside the house, the call never came at all, and we didn't discover it until the end. Now, I'm a little overselling the weaknesses of our system here, and I think it is worth admitting that, yes, I am very critical in terms of pointing out our systems, but we had a number of checks. We would calculate a cost such as housing, we'd go through that process, we would check it over and over again multiple times. We had different systems in place, but we were just acutely aware of all the places that we could introduce human error, and we're not okay with it. So things evolved. Before I joined 3 years ago, the Data Science for Social Good program built an SQLite database out of our final results. So we had one source for state and years that we could pull from. That was fabulous. Once the standard was generated, we were able to take that, turn it into a CSV, and put it into R and measure it against other data sets, like the American Community Survey, run occupational analysis using the BLS data. You know, once you have the standard and you have the median wage for an occupation, you can determine which occupations will pay enough and where they're not paying enough. And that's how we got our demographic data. We also shifted some of our report figures to R, calling upon our SQLite database. I was, very proud of that. And we spent a lot of time availing ourselves of all the offerings of eSciences. Software carpentry was one of the things that I participated in. I guess I should ask what my audience in here is if you're familiar with that. It's a nice, brief thing, I believe, 3-day workshop where social scientists can enroll and kind of get their computer set up with Bash and all of that so that you can move into using these systems with a little less pain. The winter school, which is offered by an esteemed professor whose name I cannot pronounce in my heightened presenting state, so I will not attempt to. He goes through data pre-processing using R and Python, ggplot, and integrating things like GitHub and Zotero to produce reports. We put all these things together and we were advancing. We were inching forward slowly. Lastly, you'll see that we did use AI. Now, I know there's probably a lot of opinions of AI in the room, but we felt confident to use it for a couple of reasons. One being that all of our data is publicly available. We could get most of it through an API call, unless it was state data. Don't get me started. So we didn't have any risk of privacy, violations. It wasn't protected health data. Another reason that we were really comfortable with it is we weren't running complex statistical models and projections. I could check and validate that the math was the same using pen and paper, Excel, or the R code that came out of JET. Simple mathematical transformations repeated over large data sets. Helped us craft functions, excuse me. And, use of these tools really accelerated our comfort as researchers with coding infrastructure, permitted us to focus on building systems rather than me trying to figure out what was wrong with the syntax and why it wasn't running. So please keep that in mind in that context. And
so we knew we needed some help. We were making a lot of progress. We were starting the transition that we knew we needed to make. But but we knew we didn't just need to rewrite code, which we could do using AI. Like, here's my Excel formula. Can you translate this? Help me translate this to R. And I can compare the results with, okay, yes, I'm getting the same results as I did in Excel. But we needed to think through, needed help with how we think about the whole system around it, what automated testing and documentation should look like, an external perspective on our scripting structure. We needed a GitHub-based workflow because we were really scared of GitHub. I'll admit that. It was a struggle. I had a few just day classes on GitHub and I used it, but I couldn't get it into our workflow and we needed help. And we needed help with just thinking through a roadmap for long-term sustainability. And there was a major opportunity there, but we were missing what our system needed to fully be. And that is where the Accelerator program came in, especially Enschel, who really helped us think beyond technical and into conceptual. And that was really a big shift in mindset for us. We had to stop thinking in terms of a workbook and think in terms of what is the full process for this. In Excel, I have one giant file with all these tabs and, all these hidden formulas, and there's can be some copying and pasting, and maybe we improve that with some VBA scripting, but it's still copying and pasting, and, the numbers just kind of pop out. And there was just too much room for error, but it was what we were comfortable with. So we were shifting to R, we're shifting to GitHub, and we need to think about process. Okay, scripts need defined steps. We need some version history. We need named functions. Doing our first functions was so scary. And we needed checks embedded along the way. And instead of just producing, a number at the end, we're building a sequence of transformations that we could inspect. And config files were a big shift for us. And so the mind shift that we went through, this is how it looked operationally. Before, it was raw data going into a giant workbook, and then it was final outputs. And in Excel, assumptions were often embedded. Sometimes they were hidden in cells, sometimes in formulas, sometimes just in my memory. And in the pipeline, we needed to use config files to make it really clear what we're documenting. What are the inputs that are going in? So we'd have the state, the year. If we're using a different USDA food plan, it all needed to be really clear. So if someone asks, okay, what assumptions were used for this run, it's not going to be buried in a spreadsheet. It is really clearly declared at the top in the config. And that made it so much easier to replicate, to make it where we can rerun a state with different assumptions. And ultimately, it's just explicitly the inputs reduce ambiguity. But in this transformation process that we went through, from going from Excel, a single state at a time, into a 50-state data production, what we're doing didn't change. We didn't change the definition of basic needs. All of our policy logic behind the expenses, we're still able to stay the same. Our transparency requirement didn't change. Our assumptions didn't change. And we were committed throughout the whole process that we're going to be able to explain every number. So for us, modernization was about reliability, but not about changing the substance. Okay, let's talk about that a little bit more concretely. I'm going to kind of walk you through what that would mean for one number of hundreds of inputs that go into the self-sufficiency standard. This is the earned income tax credit. And I'm just going to use it as a concrete example. So the policy logic around EITC didn't change, but what changed is how we represented that logic in our production system. So the EITC, that's a tax credit at the federal level. Lots of states have EITC tax credits as well that build off of the federal. It's not a flat deduction. You can see there's depending on your income, your earned income, there's a phased in amount, and then it plateaus for a while. And then if you're earning more, it starts to have a phase out. And then it varies by the number of children you have, as well as your marital status. So there's a variety of parameters that go into it and like the logic as far as that. And so the structure is where our Excel workflow could really get strained. And that's what we'll just demonstrate. So before, all the parameters were just on one sheet in a table in each workbook for every single state. And then the logic for that lived elsewhere in VLOOKUPs or index match statements to pull thresholds and rates in. And then we had nested if statements to implement the phase in and phase out logic. I don't know if all that makes sense, but parameters in one place, logic in another place. So that was fine, and it definitely worked. I mean, we're able to produce what an EITC amount would be, but every single family has its own output column in our Excel file, and so we're producing like 720 family types, in every county. And so that means that like each logic would be getting dragged across 720 columns. And if a threshold changed, a rate changed, a formula changed, that meant, checking formulas across every output sheet for every county. So, we didn't have a risk there that Excel couldn't compute it. I mean, we could do it, but there was this risk that there could be silent inconsistencies at scale. So where did we go? How did we shift this? The first thing was really simple. We shifted our data, our parameters, into a simple, tidy data table. That made a big difference. Instead of being embedded in a workbook tab for every single state, each EITC parameter is in a single row in a table by year, by number of children, by filing status. And that meant that we would change a number once per year. Or if we were doing a policy change, we can change it in one spot. We just update this one file, and it's not something that we're going to have to update in separate workbooks across each state where errors could get introduced. And it also means that we can track changes across years really easily. I can just shift the parameters from 2026 to, let's say I had, 2020, and what were the differences between those 2 years if I held everything just the same? What was the impact that EITC had for families? So the second shift was then separating the parameters from the logic. So before, we had these nested if statements in Excel, and now the logic lives in one block in R. We have our phase in, our plateau, our phase out, and then it goes to 0. The thresholds and the rates come from the parameter table, but the structure of the rule is clear and reusable. It's a function. We can apply that function to other states, to any other use case that we might need. And then so that is the pattern, that parameters become data and logic becomes code. And that is really the thinking around what allowed us to scale from a single state workbook to a 50-state data pipeline. And this work is very much in progress, but overall, it is reducing our cognitive load of maintaining the system this way.
So for those of you who are planning to work with interdisciplinary teams as data scientists, we wanted to give you some tips on what we found helpful in our experience with our Accelerator data scientist. Thank you. Two different computers here. First, I would really start with the process rather than code. Spend some time, get together in person, grab a whiteboard and some coffee, and really outline, start to finish, how things work. You really need to build that shared mental model. The second was making sure that we set the directory structure in GitHub repo early. Before our files, when we were in a state-by-state report deliverable mode, we had everything organized by state. We needed to shift to a repo, and what the heck was a repo? Separate out our data by raw, intermediate, processed, and from our code and from our tests and checks and configs. Don't wait too long to get them into Git. It was scary. I think we've established that. And I know that I lost code by not understanding GitHub Desktop and stashing stuff and discarding my stash, but you know what? It happened earlier than later, and it was good because I lost a lot. The learning curve wasn't as costly the earlier it took place. Next, if you're, again, I'm not sure what your career trajectory is, but if you are working to modernize a system, teach best practice. Config files, modular scripts, orchestration files. These were all concepts that we really needed worked into our flow and were patiently explained to us. Very patiently explained to us over time. Before we enrolled in the Accelerator program, AI could help me convert functions, convert simple things to functions, and check that my childcare costs, once I converted them from weekly to monthly, were actually higher, but I needed a human to tell me that I could put that formula into a function, that I could keep my script tidy by referencing it and sourcing it in, and put all my constants in a config for easy documentation, validation, and normalization. So your jobs are still safe. Teaching someone to fish. It's things are going to get messy. It was a challenge for our team to adapt. First of all, we were lucky in that we had this established shared mental model with our data scientist who could look and point directly to, our areas of high risk. It's okay. Don't be afraid to start small. We would go into a session expecting to go through a whole R script, and we would stop maybe 20 lines in because there was a basic principle that we hadn't understood or something that could be optimized, and that time was worth every second. Lastly, be patient with the teams. Remember, data science is its own language, and I'm not just talking about R, Python, Java, C++. It took some time to build that lexicon and that mental model, and there were a lot of drawings on the board of, this is your folder, this is what it does on your desktop, but this is what it does in GitHub. It checks out a copy. Really spending that time to either develop something that works for you and your teaching methods, or to draw upon something that's already, established with pedagogy, will deliver returns. as well as syncing your PowerPoint slides.
Doesn't want to go forward.
Right, good. Just skip the next
Right here.
one. Yeah, we're gonna skip it. Oh, actually, you know what? Sorry. This is your heightened your sympathetic nervous system acting out. And lastly, when the team that you're working with is just out of their league, don't be afraid to outsource. We weren't sure how to recreate that iterative tax function that works so well in Excel. But it was a key component to our cost of living measure. And there were Masters of Data Science students on campus who needed a capstone project. And we've been very fortunate to work with 3 individuals who are developing that iterative tax function so that we can direct our energies to collecting the data, standardizing it, and doing what we're good at, and handing the parts off that you excel at so that we can all work together and not waste time.
So through the Accelerator project, we have learned a lot, and we have transformed the way that we work organizationally so much. We're definitely not done with our process. The migration to R and GitHub was a big structural shift for our organization. And it's something where we're still expanding it. We need to really figure out testing more and continue figuring out our documentation and continue developing that roadmap for open source collaboration. And, our goal isn't just to run code, it's to keep on building a system that we can maintain and that we can audit and that we can continue to evolve. This isn't kind of a one-time event for us, is what we're really learning. And it's really been a big design commitment. So we're very much still learning what modernization means, what getting into R and having a single pipeline means. But I just have to say that we are incredibly, deeply grateful to the eScience Accelerator team, especially Enshul and Brenna.
And Brenna Hazelton.
Specifically. Thank you. I'll give you full names. Thank you for helping us take this step. And not only has the work that we've learned through here transformed how we do this pipeline, but it has completely translated into our other projects that the center does as well, which are now also in GitHub and that also have these thing called repos that we've been learning about. And so it's been a really great process, a really big learning process for us. So we're happy to take any questions that